Oh, hi, students. Physics students. Yes, you guys. Haha. You thought you were going to have classes. Haha. Think again. Okay, well, I'm going to torture you a little bit with circuits and series in parallel. Remember we were discussing this in class long ago? Yeah. Okay, yeah. Remember, circuits with resistors and series in parallel. Last class we discussed circuits with resistors in series. Then we did one example in series and then another one in parallel. Look at this example. Yeah, for the given circuit, I'm going to ask you to find the total resistance, right? And then later I'm going to put a case here. I'm going to put some voltage so we can find the total current, and then the current in each of these resistors. So the first thing, like it says here, resistors in this circuit shown each have a resistance of 600 ohms. What is the equivalent resistance of the circuit? Okay, first of all, look at these two. These two here, guys, you know, they are in parallel. Look at these two. These two, you also know, they're in parallel. But these two in parallel are in series with these two in parallel. The equivalent of these two resistors in parallel will be this one. I draw here. And the equivalent of these two resistors in parallel will be this one. And now you can see that these two are in series. Then you can add them easily. So the first thing we're going to do is we're going to calculate the resistance. These two fellows. Where is it? Here. Total, well, resistance is called equivalent 1, which is going to be equal to 1 over, let's say this resistor is 600 ohms plus, let's extend this a little bit, 1 over the other resistor of 600 ohms. And if you add these, use your calculator, you're going to notice that the equivalent is going to be 300 ohms. Yay! This is the resistor equivalent 1, which is actually will be this one here, 300 ohms. Now if you do, this is for this two, right? This part is for this two. Now if you do these two, you would get exactly the same equation. You would call this one resistor equivalent 2, which is going to be equal to 1 over 600, since each resistor is 600 ohms, divided by 1 over, oops, sorry about that, 600 ohms. And if you do this, the equivalent is going to be equal to 300 ohms. Yeah, so this one here is equal to 300 ohms. The sum of these two, now they are in series, the total is going to be equal to what? 300 plus 300, 600. Yay! Okay, good. Yeah, it happens that they have a resistor of 600, but they're in parallel, and the sum of them is going to give us exactly 600. But now, let's assume this, that the total voltage is equal to 600 volts. So one of the things I would ask you is to find how much is the total current. Well, total current is going to be what? Total voltage divided by total resistance, right? Or the equivalent resistance for the circuit, according to Ohm's law. So in this case, we will have that the total voltage, I give you 600 volts divided by 600 ohms, and it gives you that the total current of the circuit was just 1 ampere. Good. 1 ampere. But let's see. 1 ampere is going through this thing. What happened when the current reached this point here? There's a junction. So part of the current will go up, part of the current will go down. Then when they reach this junction, they will meet again. But what happened when they reach here? This junction means that part of the current is going here, part of the current is going here. Okay, so how we do this problem, I'll do it in a second. Now we continue here. We're going to find now the current in each resistor, right? So to do that, like I was saying, remember, part of the current goes here, part of the current goes there, and the first thing we're going to do is go to these two circles. They're in series, so that means, which here, this one represents this one, this 300 ohms represent these two. Because they're in series, the current that goes through this one is the same that goes through this one. Great. Okay, and we know it's 1 ampere. But this resistor here, 300 ohms, represent these two. Oh, 600 and 600. That means that 1 ampere, when it goes to this junction, part of it goes here, part of it goes here. How much it will go? I guess, you know, you would say it is half of 1, which will be 0.5 amperes and 0.5 amperes. Right? Yeah. The same thing when the current goes here again, and those 0.5 and 0.5 mid, when they go to this junction, 0.5 will go down here, 0.5 will go the other way. So basically, you know how much current goes through each resistor. It's going to be 0.5 ampere. How we do it by calculating here? First, we need to know that when we have these two resistors in series, the voltage that it go through this one and this one is not 600, but it will be according to Ohm's law. We can say that the voltage for the resistor of 300 ohms is equal to the current that it goes through the 600 resistor 300 ohms, and the resistance of those 300 ohms, which in this case is going to be the total current, because the current that goes through this one is the total, which is the same as here, is 1 ampere. So it's going to be 1 ampere times 300 ohms. This is equal to 300 volts. Now that we have the voltage here, 300 volts, this one represents these two resistors here. These two resistors are in parallel, so that means that the voltage here is going to be 300 volts and 300 volts. So knowing that the resistance is 300 volts and 300 volts, we will calculate the total current. Let's say the current for the first resistor is 600 ohms, which is, let's say, this one. It's going to be equal to the voltage of that 600 ohms, which actually happens to be 300 volts, divided by the resistance, which in this case is 600 ohms. And this is going to be what? 300 volts divided by 600 ohms. It will give us 0.5 amperes. Aha, that's what I said. If you remember, I said here, if it goes here 1 ampere, that means up here will go half and up here will go half. How do we calculate that one? Well, first, we found out a moment ago that the voltage for this resistor and the voltage for this resistor, because they are in parallel, is going to be the same. We found the voltage for this resistor 300 ohms happens to be 300 volts. And we know that it's going to be the same for this one, because this one is 300 ohms times 1 ampere is going to be 300 volts. And the sum of these two is going to give you the source, which is, oh, here it is, it's 300 volts. So this would represent these two. They're in parallel, they both will have the same voltage. You take that voltage, which is 300 volts, divided by this resistor, which is 600 ohms, and it will give you here the current goes through this one is 0.5 ampere. And the same thing we will do here. You divide 300 volts divided by 600 ohms, you will have 0.1 ampere. The same thing you would do here. You would divide 300 volts, because remember now you have 300 volts here and 300 volts here, and you divide by 600 ohms, it will be 0.95 ampere, and the same thing here will be 0.5 here. So the process of this thing we got here is going to be the same. And if then you add 0.5 plus 0.5 is going to be 1, 0.5 plus 0.5 is going to be 1, and 1 is the same for both, is because they're in series. We're going to do another problem, less complicated than this one, because I'm sure you all got confused. And then you're going to say it's my fault because I don't know what I explain. Pay attention! Alright, see you in a second. Bye.